Hey everyone, Mr. Hauk here. In today's video, we're going to be looking at limits graphically. Let's go ahead and get started. So before we look at limits graphically, let's just recall a few things from the previous lesson. First off, we introduced the concept of limit. And what a limit basically is it tells you how the function values are behaving as the x values approach a certain value. When we look at the notation here, we read this as the limit of f of x as x approaches c is equal to L. So basically the function values are approaching L as the x values are approaching c for the function f of x. Okay, we also talked about how for a limit to exist, the limit from the right side and the limit from the left side must converge to the same value. And then we also brought up the notation for right-sided limit, which is right here. Notice the little plus sign in the exponent after c. And the notation for left side limit, which is right here. Notice the minus sign in the exponent after c. So again, for a limit to exist, the right-sided limit and the left-sided limit must converge to the same value. We also talked about limits don't exist if, as x approaches c, the function values have unbounded behavior. And we'll see a graphical example of that in just a minute. And then we also talked about the existence or non-existence of the function value at x equals c has no real bearing on the existence of the limit at c. Okay? So let's talk about 3 ways the limit does not exist, and then we'll get into some actual graphical interpretations of limits. So one way, and the big way that we talked about yesterday, is a limit does not exist if the limits from the right side and the left side do not converge to the same number. And we can see a graphical representation of this. We can see the limit on the left side as we get closer and closer. Let's call this c right here. As the x values get closer and closer to c, we can see that the left-sided limit is going to whatever this function value is. But as we get closer to c on the right side, we can see that this is converging to whatever this y value is. And those two function values or y values are not equal to each other, so the left-sided limit and the right-sided limit are not equal. So the limit won't exist. We will also have a limit that does not exist if we have unbounded behavior at x equals c. So let's say that this is c right here. Notice that on the left side and the right side of c, we have this unbounded behavior. So we're going to go ahead and say the limit does not exist. And this looks just like the example we saw yesterday with y equals 1 over x squared. Okay? And then the next way that a limit doesn't exist is if you have oscillating behavior at x equals c. So let's say again that this is x equals c. Well, as the function, or as the x values get closer and closer to c, if we have this oscillating behavior, then we're going to have a limit that does not exist. Okay? So the way that we're going to do this is we're going to look at some examples using this piecewise function that's been graphed. Now here in the notes, a lot of this did not copy over correctly, so go ahead and change these values along with me. Let's make a the right-sided limit for the limit as f of x as x approaches 0 from the right. Let's make b a left-sided limit. C is just going to be the overall limit. Let's make e a right-sided limit. Let's make f a left-sided limit. G will just be the overall limit. Let's make I right-sided limit. Let's make j a left-sided limit. K will just do the overall limit. And I think that's pretty good for those. Okay? So what I'm going to do is I'm going to go over these examples or these problems from example 1, and then example 2, I'm going to show a screenshot of it at the end of the video here, and you can try those on your own and then just make sure that your answers match mine. Okay? So let's start with A here. We want to calculate the right-sided limit, or the limit as x approaches 0 from the right, of f of x. And f of x is graphed right over here. So we're going to go over to, we're going to look at the x value of 0, and we're going to approach it from the right side. So here's 0. We want to approach 0 from the right. So as we're looking at this little chunk, and as we approach 0 from the right, notice the y values are getting closer to 2. So I'm going to go ahead and say that the limit as x approaches 0 from the right of f of x is equal to 2. Let's put that a little lower here. Right there. Okay. Now let's look at the left-sided limit. So again, we're having the x values approach 0 from the left. So here's 0. Let's approach it from the left. And we can see that the function values are approaching 2. So remember from the previous lesson, we mentioned that if the left-sided limit and the right-sided limit are equal to each other, or they're converging to the same value, then that's going to be the overall limit. So the limit of f of x as x approaches 0 is going to be 2, because that's what the left-sided limit and the right-sided limit converge to. But now let's go ahead and look at the actual function value at 0. So, we can tell that the limit as x approaches 0 is going to be 2, because from the left and right it approaches 2. But the actual function value is here at 1. Remember, with graphs like these open circles mean that you're not defined at those open circles. The filled in circles mean that's where your function is defined at. So even though the limit as x approaches 0 from the left and the right is equal to 2, the actual function value at 0 is going to be 1. And kind of the purpose of us putting this on the notes is that we want to make sure that everyone understands the function value at 0 has no, does not affect the actual limit as x approaches 0. It's important to realize that. All right, let's try now the limit of f of x as x approaches 2 from the right and from the left. So we're looking at 2, and we're approaching on the right side first. So here's the x value of 2. We want to approach 2 from the right side of 2. So if I'm approaching from the right side, notice that we're getting really close to y values of 2. Okay? But let's look and see what happens as we approach 2 from the left side now. So as we approach 2 from the left, notice the y values, or the function values, are getting really close to 1. So what do we think? Do we think this limit exists? Well, we have to remember that in order for a limit to exist, the right-sided limit and the left-sided limit have to converge to the same value. Here, the right-sided limit is equal to 2. The left-sided limit is equal to 1. Those are two different values. They are not converging to the same value. So the limit as x approaches 2 of f of x does not exist. Okay. Again, for completion's sake, let's go ahead and look at the actual function value at 2. So at 2, remember the open circle is not defined there. So our function value at 2 is actually going to be here at 1, the y value of 1. Okay. Let's now look at the limit of f of x as x approaches 3 from the right and from the left. So we're all the way over here at 3 now. From the right side, as we approach 3 from the right, the function values are approaching 3. Let's look from the left. So now we're going to approach 3 from the left. Well, we can see that the y values approach 3. And since the left-sided limit and the right-sided limit converge to the same number, that means the limit of f of x as x approaches 3 is going to be 3. Okay? And then let's look at the function value of 3. So we look here, notice that at 3, we had this open circle, which means we're undefined at that point. But we also don't see any filled in circles. There's no filled in circles for x equals 3 anywhere. So we're actually going to say that f of 3 is undefined. Okay, a few more questions to answer. Let's find the limit of f of x as x approaches -2. Notice we're not looking at the left or the right side limit, we're looking at the overall limit. So if we're looking at x equals -2, well, we still need to look on the left and the right side. So from the right side, it looks like the function values are approaching 1. If we approach from the left side, the function values are also approaching 1. Since the left side and the right side are approaching or converging to the same value, that means the limit of f of x as x approaches negative 2 is going to be 1. Okay, so let's look at the limit of f of x as x approaches negative 1. So all right, here we are, negative 1 on the x-axis. If we approach from the left side, or from the right side rather, the y values are getting closer to 3. But if we approach from the right side of negative 1, the y values are getting close to 1. So the left-sided limit and the right-sided limit are approaching two different values, so this limit does not exist. And then lastly, let's look at the function value at negative 4. So f of negative 4, here's negative 4. Notice that we do have a filled-in circle right here. So f of negative 4 is going to be equal to 1. All right, so that's been this example, bunch of left-sided, right-sided limits, some function values, just good overall examples. I would encourage you at this point in the video to go ahead and pause it and try example 2. And then, once you've tried those examples, unpause this video and check your work. But I'm going to go ahead and scroll down to example 2. Again, go ahead and make sure that your answers are correct with what you've tried. Special mention here real quick, if you look at K, where it says the limit of f of x as x approaches negative 6 from the left. Well, notice that as we're approaching negative 6 from the left, these values are growing without bound towards negative infinity. In some textbooks, some textbooks you'll see this a little differently. Some will say that the left-sided limit approaches negative infinity. Others will just say that the left-sided limit does not exist. You can't really say it's equal to negative infinity because infinity is not a number, it's a concept. So I would be okay if you either said the left-sided limit approaches negative infinity, or if you just said it does not exist. I'm fine with either one. Okay, but again, here's the answers to example 2. Make sure that you have these down. So this has been Limits Graphically, and I'll see you in the next video.